Okay, so this is quadratic applications, vertical motion notes. So here it says vertical motion can be modeled by the formula h equals negative 5t squared plus v sub 0t plus h sub 0, where v sub 0 is the initial upward velocity. So v sub 0 right there is the initial upward velocity. T is the time h sub 0 is the time, and h sub 0 is the initial height, and h is the height of the object. Use this formula to model the situation given and then answer the questions. Alright, so let's go ahead and see how this goes here. So once again, we're just going to use this equation to write this shell of an equation, the general equation, to write our regular equation. So it says, a football is kicked into the air with an initial upward velocity of 30 meters per second. So initial upward velocity, 30 meters per second. So we know that that is v sub 0. All right, so it says find a particular equation that models this situation. So we start here. Now notice there is no initial height, so we're going to assume that initial height is going to be 0. For right now, since it's not given to us, like it doesn't say the initial height anywhere, we're going to assume that is 0. Alright, so for here it says find a particular equation, so we start with h equals negative 5t squared, that's standard, they can't change that, plus v sub 0 with the initial upward velocity, which is 30t. And once again, the initial height was 0, so I'm going to leave it like that. It says to sketch a graph of this situation. Well, here is your squared term, and notice the a value is negative, so we know that the graph is going to be facing down. And you'll see that happen on pretty much every single problem here, so that's why I only put it here once. Now it says to determine a reasonable domain and range that represents this situation here. So we're going to solve these in the calculator. So let me go ahead and just put this in the calculator and have this ready to go. So y equals negative 5x squared plus 30x. Okay, so our domain we can see is going to be from 0 to 6. So from 0 to 6 seconds. So domain, we're going to say bracket 0 comma 6 bracket. For the range, we have to find the maximum height. So you just go to the very top, we click it, and we see it's at 45. So it started at 0 and it hits the peak point of 45 in terms of vertical height. So 0 comma 45. And I'm going to include both of them. And you notice the graph was facing down. Now it says calculate the height after 2 seconds. So if you recall, time is x. So over here, I'm just going to go back over here. I'm just going to type in x equals 2. And I see it just happens to intersect right there. So I'm going to click on the intersection, and I can see it is 40. So 40, what do we have? 40 meters. And once again, since it gave me 2 seconds, I could have easily just said h equals negative 5 times 2 squared plus 30 times 2, right? And that's 4, negative 20, 30 times 2 is 60, so negative 20 plus 60 is 40 meters. And the same thing I can do 5, I could plug it in for t as well, but I'm already here, so I'm just gonna go ahead and type in x is equal to 5. So let's change this number to 5 now. And we can see that it intersects right here. Just click on that dot, and we can see that 5 comma 25. So the vertical height is 25 meters. So you see it's pretty easy. At what time will the ball be 45 meters above the ground? Okay, so height, now this was time x, so now we're going to do height, which is going to be y. So y equals 45. All right, and we'll scroll up here, and oh, there we go. So it is, let's see, read this one more time real quick. It says at what time will the ball be 45 meters above the ground, and we can see it's 45 meters above the ground at 3 seconds. When does the ball hit the ground? Well, once again, we just go over here down to 0, the x-axis, and we see it hits the ground at 6 seconds. It takes 6 seconds for the ball to hit the ground. So these problems here, you just put them in the calculator. Rock off the cliff problem. Suppose you throw a rock into the air from the top of a cliff. The initial velocity is 40 meters per second. Find a particular equation that models the situation. Once again, we don't have an initial height, so we assume the initial height is 0. But we do have a initial velocity, which is 40 meters per second. So you can refer back to the equation up here. I'm going to write the equation. So h equals negative 5t squared plus 40t. Before I start working on this, I'm going to go ahead and type this into the Desmos. So y equals negative 5x squared plus 40x. All right, so there's my graph. So the first question says, determine a reasonable domain and range that represents the situation. So for the domain, we're going to look at the roots for this particular problem. So we have 0 to 8 seconds. And I'm assuming it's time, yeah. So 0, 8, both in brackets. We're going to include both of those there. And for the range, we're going to look for that maximum height. And we know it's from 0 to my y value of 80. So 0, 80. And I'm going to include both of them. All right, how high will the rock be above the cliff top after 2 seconds? So once again, that's a t value. So I could easily say h equals negative 5 times 2 squared plus 40 times t, which is 2 again. And like these, you could work them out, but put in the calculator as well. So like 2 squared is 4, that's negative 20. 40 times 2 is 80, and it should be 60. And this is meters, right? Because this is in meters, because at negative 5t squared, it's going to be meters. All right, so over here, time is 2 seconds. So I'm just going to type in x equals 2 because that's our time. So x equals 2, and we can see we have an intersection right there at 60. Okay, so it did check out correct. My next question says, how about after 4 seconds, what's the height? So we're going to change that time of 2 seconds to 4 seconds. And here we can see that it's actually at the maximum height, it looks like it, and it's at 80. So 80 meters high. When will it again be at the same level you threw it? So I'm assuming that's when it's going to hit the ground. Once again, because the initial height is that. So we scroll down here and we see that it is 8 seconds. Now, when will it hit the water 100 meters below where you threw it? Okay, so this is a little bit different. So that they're giving us a height, so we're going to do y equals negative 100. So I'm not going to actually have to scroll down here. So bam, right there, and we see it takes 10 seconds to reach negative 100 feet below us, so 10 seconds. So that actually changes something now. It changes my domain and my range, right? Because before we just used the roots to get from 0 to 8, but now we know when will it hit the water 100 meters below. Well, the time actually goes to 10 seconds. So this 8 must be changed to 10 seconds now. So hopefully you see why I'm changing this, because the time now is 10 seconds in the situation as opposed to 8. Also, we now know that the maximum height didn't change. The max height is still 80 meters. But it was 100 meters below, so we're not actually doing 0 anymore. We're starting at negative 100. So this one's going to be negative 100 and a bracket on there. All right, and those are the answers using Desmos. But once again, you can also use just algebra to do it as well. And that concludes the notes.